Welcome to Pharma Guru. What is theoretical plate or column efficiency N and how to calculate it? Theoretical plate or column efficiency. Theoretical plate or column efficiency in HPLC and GC tells about the sharpness or narrowness of the chromatography peak. Let us consider a chromatogram contains three peaks. Peak 1 is for benzene, peak 2 is for naphthalene, and peak 3 is for anthracene. You can see in the chromatogram, benzene peak is more sharp compared to naphthalene peak, and naphthalene peak is more sharp than anthracene peak. In another word, we can say that as we are going from benzene to naphthalene and naphthalene to anthracene means sharpness of the peak is decreasing. It means theoretical plate is decreasing. Now question comes, how theoretical plate is calculated? I am going to explain the same in next slide. Calculation of the theoretical plate. Theoretical plate is calculated by the following formula. Formula number 1, N is equal to 16 into T divided by W whole square. Formula number 2, N is equal to 5.45 into T divided by W whole square. N is equal to 4 into T divided by W whole square. This is formula number 3. In industry, formula 1 and 2 are widely used. In formula 1, T is the retention time, W is the width of the peak at baseline of the peak. Whereas in formula 2, T is the retention time, same as formula 1, but W is the width of the peak at half height. W is the width of the peak at half height. Now question comes, in which case formula 1 will be used and in which case formula 2 will be used. I am going to explain the same in next slide with case studies. Case studies. Let us consider a chromatogram contains a peak which is eluting at 5 minutes and width of the peak is 0.5 minutes. Now let us see how theoretical plate will be calculated using formula 1. Formula 1 is N is equal to 16 into T divided by W whole square. Since here T is 5 and width is 0.5. Hence N will be 16 into 5 divided by 0.5 whole square, which is equal to 1600. It means N is very low and hence what will be the peak shape of the peak? The peak will be like that, means peak is broad. Now I am going to discuss how N will be calculated using formula 2. Let us consider a chromatogram contains a peak which retention time is 10 minutes and width of the peak is 0.2 minute at half height. Now how formula 2 will be used to calculate the theoretical plate? N is equal to 5.54 into T divided by W whole square, where W is the width of the peak at 50% height of the peak. Here T is 10 minutes, 10, width of the peak is 0.2 minutes, this is 0.2, then N will be 5.54 into 10 divided by 0.2 whole square, which is equal to 13,850, means high. It means what will be the shape of the peak? Shape of the peak will be like that. Peak will be sharp. Now question comes, in which case formula 2 will be used and in which case formula 1 will be used. When your peak is sharp, in that case use the formula 1 to calculate the theoretical plate. But when your peak is broad, in that case you use formula 2 like clarithromycin, azithromycin, erythromycin, etc. Now question come, what are the factors affecting the theoretical plate? Factors affecting the theoretical plate. Column temperature. N is directly proportional to column temperature. It means when you are increasing the temperature, theoretical plate will increase. Stationary phase, purity and chemistry. When you are decreasing the particle size, in that case theoretical plate will increase. When you will increase the size of the particle size, in that case theoretical plate will decrease. In another word, we can say that theoretical plate is reversely proportional to size of the stationary phase. If your stationary phase purity is high, then your theoretical plate will be high. Buffer concentration. N is directly proportional to buffer concentration. Higher the buffer concentration, higher the theoretical plate. Peak set. Sharper the peak, higher the theoretical plate. Broader the peak, lower the theoretical plate. Injection volume. Theoretical plate is inversely proportional to the injection volume. When you are increasing the injection volume, theoretical plate will decrease. When you will decrease the injection volume, in that case theoretical plate will increase. Analyte concentration. Theoretical plate is inversely proportional to injection volume. When you will increase the injection volume, in that case theoretical plate will decrease. When you will decrease the analyte concentration, in that case theoretical plate will increase. Peak tailing. Higher the peak tailing, lower the theoretical plate. Means when peak tailing will increase, theoretical plate will decrease. Retention time. Theoretical plate is directly proportional to retention time. When you will increase the retention time, then theoretical plate will increase. When you will decrease the retention time, theoretical plate will decrease. Peak width. Theoretical plate is inversely proportional to peak width. Means when peak width will decrease, theoretical plate will increase. When peak width will increase, in that case theoretical plate will decrease. Now question come, what is the acceptance criteria of the theoretical plate? Theoretical plate acceptance criteria should be kept based on the trend data and rational justification. Generally, for HPLC analysis, theoretical plate is kept more than 2000. But for some of the molecules like azithromycin, clarithromycin, we are not getting the theoretical plate high after all changing in the chromatography condition. In that case, lower theoretical plate can also be kept. We are also offering several pharma courses. You can join our pharma courses. The following are details. Thank you. Let us see you in next session.